Welcome to Vulnerability Stadium. I'm Brian Chess, chairman of Iron Chef Black Hat. Today, together with my co-host Jacob West, we will bring you the first Iron Chef Black Hat. If you're unclear on what that means, here's a start. We love Iron Chef. We love the idea, just the absolute ridiculous idea that you can have two chefs compete and that you can give them just a ridiculously small amount of time to whip up something absolutely amazing. So, that's what we're going to do, but we can't cook. So, instead, we're going to do this. We're going to compare vulnerability analysis tools in a head-to-head bake-off. Here are the rules. Each of the chefs get 45 minutes to find vulnerabilities in the same piece of code. They haven't seen the code before. They can only use tools that they have written in order to analyze the code. The secret ingredient, just as with Iron Chef, is the code. When they're done, when their 45 minutes is up, they will present their results to a panel of celebrity judges who will select the winner. We'll ask the judges to look not only at the quality of the findings, but also the originality and the presentation that they get when they receive the findings. So the first half of the majority of the presentation will be the bug hunting portion. Then the first chef presents, and then the second chef presents. Our first chef today, Toshinara Correa. Specialty. His specialty is runtime analysis. He is a lead engineer at Fortify Software, and he will be assisted by Eddie Lee. Toshi is no stranger to risk. This is him practicing BMX tricks on his tricycle. Our second chef today is Sean Fay. Sean's specialty is source code analysis. He is a lead engineer at Fortify Software, and he will be assisted by Jeff Morrison. This is a picture of Sean and his extended family. This is Sean. This is Sean's younger sister, Kathleen. Sean's no stranger to black hat techniques, but he's matured, we think. He now tries to avoid being caught on film. All right, so we've got two guys from Fortify up here on stage. Maybe that might seem a little funny to you one way or another. So let me say this. If you'd like to get another tools vendor to come up on stage with you, there are two possible things that might happen. First of all, that vendor may believe that they are inferior to you, in which case they're going to be afraid to get on stage with you for fear that you'll make them look silly. The other possibility is that that vendor may know that they are superior to you, in which case they won't get on stage with you for fear that you'll make them look silly. So, what we're going to do today is ask you to join us in looking at this code. After we get through with the 2 rounds of judging, we'll ask you to point out the bugs that these guys missed. The best bug that both of them missed gets dinner with us tonight at Bouchon. Jacob, why are we going to Bouchon?
Thomas Keller's restaurant.
Thomas Keller, the guy who did French Laundry up in Napa. All right, our celebrity judges are John Viega, VP and Chief Security Architect at McAfee. Jeremiah Grossman, Founder, CTO, White Hat Security. And Bogdan, President of Hackistan. And now it is time for us to unveil the secret ingredient. It is JSP Wiki. version 2.579. The language it's written in Java and with some JSP, of course. It's approximately 124 kloc, so that's a little bit more than you might like to read if you just had to sit down and only had 45 minutes. Home is jspwiki.org, and they describe themselves as a feature-rich and extensible wiki engine built around standard J2EE components. Here's your code. Anyone else who would like to join us looking at the code? USB sticks are up here.
Here you go.
Please recycle. We didn't bring enough for everybody. Gentlemen, you may begin. The clock is ticking. Which button did we push, Jacob?
Your screen, right? Sure.
Jeff brought a timer. What a courteous guy. The code is unpacking on that side. What are these guys doing? Oh, they're going for the GUI unpacker.
This is like watching the beginning of the episode.
So Jacob, you want to do a few?
Yeah.
You want to introduce it?
So while we're doing exciting things like watch the zip file unpack, although maybe he's finished now, we asked the chef some questions before today, a little background, various things, and Brian and I are going to go through the questions and then take turns sharing the different chefs' responses to the questions. Brian, you want to take the first one?
The first question we asked was, how many lines of source code are in your tools, and what programming languages are they written in? Sean says, the static source code analysis tool is about 1 million lines of a combination of Java, C, and C++.
Toshi is actually going to be using two tools today. His fuzzing tool is about 20,000 lines of C#, and his bytecode monitoring tool is about 50,000 lines of Java.
Lean and mean, these guys.
Okay, next question. Do you use any open source components? If so, which ones? How about closed source components? Toshi responds, on the Java side, Tomcat, Struts, AspectJ, Hibernate, HSQL. He likes open source a little bit. On the .NET side, it's built on top of Visual Studio Test Edition, and he uses the .NET framework, not quite open source.
Wait, did you see what was happening over here? He started a static analysis tool and he got a bunch of errors right off the bat, and it seems to have flipped him back over to Windows mode.
This is what happens when you do live demos.
All right, so let's see. For the static analysis side, on the open source components, sure there are open source components like bcell, which is used for Java bytecode parsing, and also some closed source stuff like the C and C++ front end from the Edison Design Group. Back over, they're off and running again. Jacob, what's going on over on the runtime side?
I'm trying to tell. It looks like they got the application up and running, so that's a good sign since they're going to try to test it at runtime.
You know, I should let you run this. Do you want to go on to runtime analysis, or should we do another question or two now?
We could do one more question. So the last one we'll do now is, how long have your tools been around? Toshi's tools are pretty green, so both of them have been around for less than a year.
Sean's a little ahead on this front. I guess that shows because he's got more code. His tools have been around for about 3 years.
So anything exciting on this screen left? Okay, so what we're going to do while Sean gets a scan kicked off on his side and the runtime guys keep doing a little, looks like manual fuzzing over here, is tell you a little bit about Toshi's approach to testing today. And then after that, later on, Brian will do the same thing for the static analysis tools. Unfortunately, we couldn't get 16 screens in the room at once, so we're going to have to do a little switching back and forth. Okay, so Toshi's approach, I mentioned before, he's coming at it with two different tools. So he's got one tool that's a traditional black box pen testing tool, and one that's more of a white box analysis tool. On the black box side, this is a similar approach to tools you've heard of from Sensix, Spy Dynamics, Watchfire. Toshi's tool has a couple of unique factors. One is it's built on top of the Visual Studio Test platform. So he leverages some of their testing capabilities as well as giving people the ability to use existing test scripts to exercise an application. Unfortunately for him, we didn't give him any test scripts today, so he's starting from scratch. Now, everybody in the room, I'm sure, is an expert in black box testing. I'm going to give just a summary overview of what he's doing. So there's traversing the application and there's testing the application. Traversing usually comes in two forms. So you can manually go through. The disadvantages of this are that it can be pretty time-consuming to exercise the whole app. The advantage is you have a better chance to actually get everywhere. On the automated side, much easier to do. You just point it at a URL, it's going to crawl the application, potentially do a pretty good job of exercising it with very little human input. At the same time, it has a difficult time with complex interfaces. AJAX is a real problem here. And it can take a little while, too, because it's not very intelligent about the routes it's taking through the different pages. Now, on the testing side, we're going to talk about two techniques that Toshi's going to leverage today. One is signature-based analysis. So you provide some input, and based on the HTTP response you get back, you look for patterns, such as a SQL exception, maybe indicating that you've got a SQL injection vulnerability. Behavioral analysis is a little more complicated. So you're looking for potential changes in the way you can affect the application's behavior that are indicative of a vulnerability, even though there's no clear pattern that's coming back in the response. So an example is blind SQL injection. So you submit a normal request, and you see what kind of behavior you get back. Then you submit an injection attack that you think is going to change the query to be true all the time, and one that you think will be false all the time. You compare the behavior between these, and from that you can sometimes derive that there may be a vulnerability underneath, even if it's not evidenced as clearly as an exception or stack trace coming back to the screen. So advantages to black box scanning overall, and this is in contrast with static analysis, are if you've got an application running, you can test it. Point it at the URL and you can get started. You'll likely find some bugs. So I expect to see, we don't see what's on Sean's screen right now, these guys get started a little more quickly. Of course, they do have to get it up and running, so there's a little overhead there. And second, once you do find a bug, and I think this will definitely play in today, it's much easier to verify that it's real, because you've already got a reproducible test case, you've got some input and output that evidences the problem. You've got a pretty easy case justifying that it's a real bug. Static analysis, and we'll see, these guys are going to have a little more trouble proving that it's a real problem. And we expect our judges to keep this in mind when they're scoring them. So, disadvantages, potentially, of black box testing. You can only test what you can exercise. So if you miss part of the application, you're not going to find any bugs in it. And also, there's the possibility that you don't have the right oracle to identify a vulnerability. So if the vulnerability is evidenced through the web interface, you've got a pretty good chance at identifying it. If, however, it results in a change on the file system or a command being executed on the server, and that isn't evidenced back through the web interface, you may have difficulty identifying that because the only point of input you have interaction is through the web. So Toshi combats that with a little bit of special sauce today. He's got a white box testing tool.
Jacob, let me interrupt for a second. Can I flip back over to Sean?
Absolutely.
Sean has finished analyzing the code and has just brought up his results in the Results Explorer. So he's starting to look at what might actually be in this code.
Who's ahead at this point? Have these guys found any bugs yet?
Not yet.
I see lots and lots of stuff going on the screen, but it's not so easy to tell what phase of the analysis they're at. It looks like Toshi is going through reams and reams of stack traces. That could be good, that could be bad.
Okay, so we were talking about Toshi's special sauce, which maybe has something to do with these stack traces. I'm not sure yet. The idea is you insert some monitors into the application's binary that give you a little visibility into those other interfaces. So what do you want to instrument in that way? Sources of input and potential sinks. So places where vulnerabilities might occur. Places where you execute database queries, places where you access the file system, places where you execute commands, access the file system, sorry about that. And you look for problems. This helps with that oracle issue that we talked about before. So how can you identify when a vulnerability has actually occurred? Some of the benefits are you get the ability to measure how much of the interesting APIs have you actually covered. So if Toshi runs this tool, runs his black box test, and sees a coverage number of 1%, he knows he's probably not getting a full picture of the bugs in the application. If he gets it up to 70, then in 45 minutes, he's probably not going to try to max it out much more. He also gets some code level details. So as opposed to a vulnerable URL, now he actually knows the line of code where the vulnerability might actually exist. And as I said before, you get access to improved oracles. So you can tell vulnerabilities where data is written out to the file system or another external interface. So this animation, which you can tell I'm not exactly an artist, illustrates the difference between the two approaches. So traditional black box testing, you throw some input at the application, and you watch the response coming back and try to make a decision based on that response. Now, this is the exciting part. Hold on. Toshi's approach, you insert monitors into the application. Input comes in the same way, but now you can tell everywhere that it goes. So you monitor all these other APIs throughout the application, and you get a lot more visibility into potentially what's going wrong. And we'll see some examples of this on his screen later on. So how do you go about inserting these monitors? Obviously, you could write them into the source code when you're developing the application, but that kind of defeats the purpose since you're probably not the one developing the application. In this case, they're written as aspects, and we're going to use aspect-oriented programming to modify the bytecode and insert them just before you deploy the application. The biggest advantage of this is that you don't need any source code. So we've given the code to these guys so they can investigate it as they want to, but their tools actually aren't going to leverage it. The idea in the Java case is you've got a class file, you've got some monitors written as aspects, you pass them through aspect_j, out comes a new class file with the monitors added on. If you imagine you've got this getStuff method, the interesting query here is, the interesting method call here is execute query. So we're worried about potential SQL injection. We've got an aspect that says every time you see an execute query call, insert a monitor that checks the query string for various patterns. And out the other end comes a class file that represents the code on the right. So to summarize, Toshi's black box tool is really a smart fuzzer. So it's using, just like the other vendors in this space, it's using known attack strings, things that are designed to exploit certain kinds of vulnerabilities, to fuzz the application, look for vulnerabilities using a couple of techniques, signatures and behavioral analysis. His white box tool is injecting monitors and looking for potential limitations based on how much of the application he's covered, getting code level, API level details, and getting more enhanced oracles for different APIs, different kinds of vulnerabilities. What's going on Sean's screen now?
It looks like he's still cranking through results. He's in the HTTP response splitting class and stepping through traces through the code.
And it looks like he might have forgotten what HTTP response splitting is because he's got the description for the vulnerability category up too. Sean, is that helping you out?
Jacob, what do you say we go back to talking about some more interview questions?
What have you got next, Brian?
What's your favorite type of security vulnerability?
Toshi likes command injection because the next step after that is usually owning the box.
Sean says there are a lot of good ones out there, but it's hard to beat buffer overflow because it's got a certain timelessness to it, and it's a classic that never goes out of stock.
The next one is a little deeper. Do you have any advice for people who want to get the most out of their tools?
Sean says customize. You can find a lot of good problems out of the box with static analysis, but every application is different, and you can usually get a lot more out of a tool if you write your own rules.
That answer gets an F because it must have been cheating. Toshi says customization goes a long way.
You know what I think it is? I think these are two guys who work a lot on tools, and they appreciate smart, engaged users.
How about users who do some of the work for them? I think that's pretty good, too.
Next question. Do you have any advice for people who want to create their own tools?
Toshi's got a two-part answer. First off, he says, I hope you don't have a social life, because it takes a lot of work. Secondly, he says, seriously, it's easy to make a tool that kinda works. The hard part is making it work all the time.
Sean says that you should try and build on what's already out there. First, identify what you want your static analysis tool to find, and then see if there's a framework that you can build on top of to do that. There are a lot of good open source static analysis platforms out there, and if you can avoid building something from the ground up, you'll save yourself a lot of time.
Kind of on the inverse, do you have any advice for people who want to create their own tools? Did we do that one already?
Yeah, that was one we just did.
Sorry about that. What's the most important thing you do in your job?
Sean says sitting down with users.
Toshi is obviously cut out for management. He says prioritization and guidance for his team.
The next question. How did you get interested in security?
Toshi's got a good one for this. It's kind of nostalgic, actually. In college, we used to use Unix write and talk commands to talk to each other. Then I realized if I dump a core file to the write command, then the other user's terminal is essentially flooded with junk. I thought that was pretty cool.
Sean says he's not interested in security. He's just in it for the ladies.
Next one, where did you grow up?
Sean's from Ipswich, Massachusetts.
And Toshi's from Japan.
Oh, I like this next one. Why do you think you're going to win the competition today? Sean says, because if the tool falls apart on this code, Jeff Morrison has a static analyzer in his brain.
Toshi's taking a politically sensitive approach to this one, and I hope this doesn't get him in trouble today. 2 runtime tools companies just got acquired recently, and he says, would you want to bet against HP and IBM?
Next question. What other software tools do you take inspiration from? Sean says he likes tools that make developers' lives easier. IntelliJ is the one in particular that he called out. He's also learned a lot from looking at other static analysis tools like FindBugs.
Toshi didn't answer this question, so I'm going to fill in my analysis for what I think his response means, which is that he's only inspired by his own tools. He doesn't like anybody else's. So what's going to be the next big thing in security?
Sean says he thinks that it's going to be runtime tools like the ones that Toshi is using.
Well, that was a friendly answer. That must have been for copying
nice.
the other
I hope
one.
that's not an olive branch of some sort.
So Toshi's response is somewhat diplomatic as well, which is he thinks static analysis and runtime analysis tools will start to play more with each other and feed output from one into the other and gain some benefit from that hybrid approach.
Okay, let's get right down to the point. Next question. Are false positives a problem? And if so, what do you do about them? Shall I go first for Sean? Sean says definitely false positives are a problem for static analysis because false positives make life harder for the user of the tool. But they're a fact of life, and the strategy is to minimize false positives where possible, but to make it easier for users to understand results so they can figure out whether they apply in their environment.
Toshi says false positives aren't a problem. I think he qualifies that with, there are a few false positives, but false negatives are a much bigger issue. So he spends most of his time trying to reduce those. All right, Brian, what's going on over here? Oh, that's a good one.
Why? Why did you jump on that one?
I saw a big red X on the screen on an error message. I couldn't tell what it said, though. Did anybody catch that? That's not very exciting.
Well, that's helpful. I guess that's what you mean by helping the user, Sean?
I'm going to peek in over Eddie's shoulder since we can't project his screen. He's got the application up. Oh, it is. What's on Toshi's screen then? So Eddie's got 5 cross-site scripting vulnerabilities on the screen. That sounds pretty exciting. And Toshi's still playing around with the app. Are you setting up a wiki?
That'd be a good way to present your results, I think.
Yeah, that's much better than PowerPoint. We should think about that. Extra points, I think.
Okay, next question. How do you prepare for the competition today?
True to Las Vegas style, and I think Iron Chef as well, Toshi tried to make reservations at Nobu, didn't get one, so he's feeling a little underprepared.
Sean went with a food-related preparation regimen, too. Meditation and a strict diet of lentils and rice milk.
And beer. So, if this were the original Iron Chef, what would you cook?
Sean says peanut butter and jelly because he's not a very good cook.
Oh, Toshi went the other way. Butter poached lobster, but he's eating them all himself, no sharing with the audience.
Okay, Jacob, you want to set me up and we'll take a look at static analysis?
Sorry, Sean.
All right. So, you may be familiar with static analysis tools that started coming out around 10 years ago. I'm talking about tools like ITS4 and Flaw Finder and RATS. Let me tell you, these tools are essentially prehistoric. Sorry, John. John's one of the authors of RATS. Oh, and it's 4. Hey, I didn't mean to cut you out. Okay.
So if Sean loses the static analysis vote from John, you know why.
So here's what these tools were good for, though. These tools basically were a fancy kind of grep. They were a good way to collect a body of knowledge about what could go wrong and then apply that knowledge to a big body of code. That's great for security experts who need to go through and do a code audit. It's also really good because you've got a place, a repository for your set of bad coding practices. The thing that was bad about these tools is when people who wrote software or who weren't security experts got a hold of them, they figured out, oh, wait. This isn't a bug finder. This is like some sort of code audit tool. Essentially, these tools weren't incredibly helpful to people who didn't have a lot of security expertise already. So, now I'm going to tell you about what probably the number one thing that the new generation of static analysis tools do that differentiates them from the old bunch.
Sorry to interrupt here, Brian. We're up to 13 cross-site scripting bugs on this side. Eddie's making progress.
Cross-site scripting vulnerabilities in a wiki? What?
No, I don't believe it.
Okay, so the advanced static analysis tools do a much better job of prioritization. And the code that I put up here illustrates that point. It's got 2 calls to strcpy in it. So when should you be calling strcpy? You shouldn't be calling strcpy, right? So it's very, very reasonable for one of those old tools to call out both of those calls to strcpy and say, I don't like either one of these. These two are not equivalent, though. One of them is much, much worse than the other because one of them just copies over a static fixed-size string into a fixed-size buffer. The other one takes user input and tries to jam it into that fixed-size buffer. One of them is exploitable, and the other one isn't. So it makes a lot of sense for the siren to go off when you see that second call to strcpy. And that first call to strcpy ought to be like, you really shouldn't do this, but you're probably not going to get burned on it today. So prioritization is probably the number one thing the new security tools do. So let me give you a pitch for why static analysis is good for security. You know, people use static analysis for all kinds of stuff. They use it for, when you do type checking, when you compile your code, that's static analysis. But let me tell you why it's particularly good for security. It's really fast compared to manually reviewing the code. Has anybody gone down that route? Anybody take the code? Hey, I think we got at more than 15 minutes yet. Boy, would you be a Jedi Master if you started bug hunting now. Come on up and get some code, though, if you want to.
How many people do we have looking for bugs right now? Wow.
I see a couple hands, but I bet a couple more people are like too lost in the code to raise their hand.
No one's listening to me.
Okay. Doing static analysis is fast compared to testing. Because when you do testing, you've got to actually put the software in all of the different states that you want to look at. Static analysis can sweep through the code and treat it all essentially in a consistent and complete manner. The static analysis tools bring their knowledge along with them. They make it possible for non-experts to contribute to a security code review process. Finally, the static analysis tools are useful for all kinds of code, not just web applications. They're not nearly so reliant on what sort of protocol the code is speaking. All right. Before you get too excited, I have to say that static analysis is not perfect. You can't find all kinds of defects this way. And let me give you a couple reasons why. Static analysis tools don't understand the architecture of your code. And that means they can't tell you what the most important place you're receiving input from or what the most important and critical operation is in the code. You have to bring that knowledge to an analysis of the static analysis results. The static analysis tool doesn't by itself understand the semantics of your application, which means it doesn't know what critical operations look like. And lastly, it doesn't understand the social context in which your application runs. Some vulnerabilities aren't even vulnerabilities if they appear in the right kind of application. You have to bring that analysis along with you in order to interpret the static analysis results. Here's a nice thing about static analysis, or any analysis tool really for that matter. There are really only 2 mistakes you can make. You can either report a bug when there is no bug, or you can fail to report a bug when there is a bug. False positive means you pointed out something and it didn't really matter. They result from the static analysis tool having an incomplete or an inaccurate model of the code, or performing a conservative analysis. In other words, it would rather err on the side of caution and tell you about an issue and let you decide whether it's important or not. Static analysis tools generally generate false negatives too, so they miss some bugs. They can miss bugs for the same reasons they report things that aren't true, and that is their model of the code might be off. They might be missing rules that tell what's a bug or what's not a bug. Or they may perform some sort of forgiving analysis where they say, that's really not going to go wrong. Okay, so now I'm going to talk a little bit about what makes static analysis tools tick. Essentially, you've got to take the source code, turn it into a model of the program, then apply analysis techniques, one or more analysis techniques, and then finally hand off your results to a results viewer. So, people often focus on the algorithm as being the key component of a static analysis tool, but I want to talk about a couple of other things that are key components. The second one on this list is language support. You know, that one is so obvious, I think sometimes it just gets overlooked. Capacity is important because you want to be able to make sure you can analyze your whole program at once. The rule set that you use to analyze the code is critically important because it tells the analyzer the difference between good code and bad code. Finally, results management, including prioritizing the issues. We already talked about that one. Controlling what to check for. If you have a bunch of rules, but you know that they don't all apply in one context or another, you might want to narrow that down. And finally, if you do have to look at a false positive, you'd like to not ever have to look at it again. Okay, just a few words on analysis techniques. I'm going to give an example here of doing static analysis for taint propagation. The idea is we've got some input that comes off of a network and goes into a buffer. We copy that buffer around through the program, and then at some point call exec on it. I'll call that a command injection vulnerability. What the static analysis tool does is it traces the potential path of execution through the code and points out where input enters the code and where that could be used against the program. Of course, this is a very short example. The sorts of things we've seen Sean have on his screen have crossed method boundaries. Parsing, language support is at the top of that list. Supporting one language or compiler, that's maybe not an easy task, but it's at least a straightforward one. Supporting a lot of languages and compiler combinations is tough. Analyzing compiled code is one potential way you might get around that. In other words, who cares what the compiler does? Let me just take the binary and look at that. After all, everybody's got it, and you don't have to guess at how the compiler is going to transform that stuff, and you don't even need rules to tell you about how to model the behavior of the compiler. There are a few problems with looking at the binary too. First of all, decompilation is difficult. It's not so difficult for Sean today if he'd chosen to go that route because he would be looking at Java bytecode. That's pretty easy to reverse. If you look at native executables, though, that decompilation problem becomes a lot harder. The loss of context that you get from looking at compiled code can hurt a lot too. If you think about what a JDBC driver looks like once you've compiled it, it looks like take some stuff, put it on the network, get it back from the network, hand it off again. You can't tell that there is potentially SQL injection in there. Lastly, even if you look at the compiled code, you still need the source because there's no way you're going to fix the bug unless you can find it in the source code. Next, I want to talk about scope versus performance. I talked about doing taint propagation. There are taint propagation and related techniques generally take more time and act better if you give them more of the program to look at. So along the bottom axis, I talk about analysis scope. Those early tools like RATS and ITS4 were really looking at one line at a time. Tools that are more sophisticated, like the one built into Visual Studio, MS/Analyze, looks at more like a function or maybe a module at a time. The static analysis tools that are generally aimed at security these days look at a whole program or maybe even a little bit more of a program, but generally speaking, they're not going to run in the blink of an eye. Now I want to talk just a little bit about rules. So I'll talk about one type of rule being structural analysis, and this is essentially equivalent to what those old-fashioned RATS ITS4 flaw finder tools would do. I've got an example implementation of a structural rule that just flags a call to getS. And that's really all you need if somebody calls getS. That's a security vulnerability right there. You don't need fancy analysis in order to catch that. I'll put a more sophisticated structural rule up on the screen next. The idea is if you call realloc on a buffer and assign the result into that same buffer, if the call to realloc fails, then you may have just leaked that memory. And there's a structural rule up on the screen that describes how you can explain that property to the analysis engine.
Brian, I want to interrupt for a second. We actually have a new entry into the competition. Eddie is pulling up a proxy tool to do a little manual fuzzing, it looks like.
Hey, can we put the results on the left on the screen, or is that hard? I'm sorry, on your left, Jacob, all the way over. Because I see Eddie got results out of the testing tool.
We can try. You can keep talking.
I don't want. Okay. He's got some
Those
up
are
there.
the same results.
So he's in Visual.
Both tools are telling me about the same thing right now, it looks like.
He was in Visual Studio. He's still in Visual Studio, and the tool is still running, is the way it looks to me.
Only 48% finished, and he's about halfway through his time.
Mm-hmm. All right. Next up, we're going to talk about analysis rules and look again at that data flow or taint propagation example from earlier. So the idea is we're going to follow values through the program, but what kind of rules do you need in order to do that? The first thing you need is a source rule that tells you get input from network means an attacker might be able to control that value. The function get input from network is the one we're talking about, and we'll establish a post condition that says the return value from the network is tainted. The next thing we need is to look at that, the analysis engine, take that buffer and watch that it makes its way onto the next line. Then we'll define a pass-through rule. The pass-through rule basically wants to explain what copy buffer does. It takes the contents of the buffer on the right and puts it into the buffer on the left. So that's a rule for the function copy buffer with another post condition. That post condition is the second argument is tainted, and then if the second argument is tainted, that means that the first argument becomes tainted. Generally speaking, in order to do a good job of analyzing this code base, my guess is the static source code analysis tool had to apply thousands of these rules. Finally, we'll take a look at a data flow sync rule. This is basically the money shot. This is where we say if you see a call to exec and a precondition for exec is if you see tainted data make its way to exec, that means you've got a vulnerability. All right. The final point I want to make about the static analysis tools is about the interface. The interface is probably the most ignored critical aspect of a static analysis tool because it's the part that's got to convince a programmer that there's a bug in their code. Generally speaking, programmers aren't looking for some sort of little robot piece of software to come out and tell them what they're doing wrong. So you also have to apply this interface in more than one scenario. Consider a case where a security auditor is parachuted in and needs to take a look at 2 million lines of code, or maybe just 128K worth of code, but in a really compressed time span. They want one interface, whereas a programmer who's doing a desk check of their own code probably wants a different take on that same data. A third interface you might want for supporting a collaborative sort of code review scenario. I'd say that the interface is just as important as the analysis techniques that you apply, because if you can't convince somebody to change their program, then it doesn't matter whether you've done any analysis or not. Lastly, that interface is where you want to show, where you want to make sure that somebody doesn't have to look at the same bogus result more than once. So you need some kind of suppression system to make sure that they stay on track.
Okay, time check for the chefs. You guys have 15 minutes left.
15 minutes total, or 15 minutes to look at the code? 15 minutes before
15 minutes
presentations begin?
Exactly.
All right. So, last point on this slide. If you'd like to take a look at a static analysis interface, please go check out the Java Open Review project. Essentially what we do is we pull in open source projects and we analyze them using Sean's static analysis tool, and then we shoot those results back to the people who made that code. We've got a couple of sample projects online. One of them's for the OWASP WebGoat project, which, glory be, has security vulnerabilities in it. And so you can kind of get a hang of what this interface looks like. You can Google Java Open Review or go to opensource.fortify.com. Lastly, I don't know if we've caught Sean with this on his screen yet or not. So I sort of showed what data flow looks like through the code, but hopefully we'll see here in a couple minutes that he's using an analysis trace feature built into the GUI tool that basically gives him a very UML-like breakdown of what that path through the code is. You can see that, let's see, all the way over on the right-hand side of the screen is where the tainted data enters the program, but that's 3 levels down deep into the call stack already. So that tainted data actually makes its way back up the call stack before it makes its way to the sync node all the way over on the left-hand side of the screen. All right, that's the end of the static analysis talk. Can we flip back over and see what Sean's looking at now?
How about Jeff?
Yeah, show him part of the screen then.
They decided to go back to their real resolutions as opposed to the little small one that the projector can handle, and now they're worried that it's going to blow up. Let's see what happens. Maybe we'll get a little bit.
Take down my machine.
Oh, Sean thinks I'm sabotaging him now. He said I crashed his computer by changing the switch next to him. All right, Toshi, you have a time advantage now. Sean's machine is completely frozen. Go for it.
What else could we use to handicap these guys at this
We
point?
could switch to Jeff's machine, too. Maybe it'll have the same effect. So we're on an error page. I'm sure there aren't any cross-site scripting vulnerabilities there. You don't have time to make a new logo. Oh, he's thinking about presentation material.
So how do we handicap these guys at this point in the presentation? Can we switch to Toshi's monitor?
Nothing interesting.
But there are more stack traces. I like those. Which one?
So Toshi seems to have gotten results out of the client or the server-side instrumentation, and so he's looking at a stack trace that he got by shooting some data at the program, and then apparently something interesting happened. Jacob, did you see what kind of vulnerability he was looking at?
Looks like this is one of his cross-site scripting bugs from before, with a little more detail.
Jeff's got one of those pretty data flow pictures up on his screen. Come on, Jeff, plug us in. Plug us in.
You crashed my machine and I'm mad at you.
You already have it sitting next to a PC. Isn't that too much?
Oh yeah, so you can see the data flow diagram up there on the screen that he's using, but maybe not enough, maybe at not a great enough resolution to tell what's going on. There's a big bad.
Well, Toshi managed to hose the layout for his application. I don't think that's what it's supposed to look like. Is that the font increase exploit?
So here's what I'm really interested in looking at when these two guys do their presentations. I think there are a lot of people in here who maybe outsource some of their penetration testing. I want to see whether these guys come up with what looks like about 2 weeks worth of penetration testing work. I don't expect they'll have a fancy plastic folder over their material, but if they've got the basic results for 2 weeks worth of penetration testing, that might be an interesting implication on what people are paying for these days.
But there won't be any recruiting allowed during the presentation, so stay away from him.
You've got to wait till he gets off the stage. Whoa, Sean's got an epic data flow trace up here. Can we flip back to him and kill his machine again?
Go for it.
He's making way too much progress.
Using his, I'm taking my resolution back.
Yeah, you see, he's got something that looks like there's got to be a tremendous amount of code that this vulnerability is flowing through, and that's what's causing those big stripes down the screen.
The question, of course, is will the judges like it?
I think if you find well, I mean, generally speaking, the longer that trace is, the more chances the analysis has to go wrong. But the harder it would have been for Toshi to find that same bug because he would have had to activate exactly that path through the application. So it's kind of a risky move going with something that's got a really long trace involved.
I was distracted by the data flow trace over here. Sorry, you missed your 10-minute warning. You have an 8-minute warning now.
8 minutes, and Sean has flipped over. Hey, I don't think you wrote that tool yourself, Sean. That looked like PowerPoint. Oh, Jeff unplugged himself again. He's got his IDE up on the screen, and he's still going through more issues. You might as well keep working right down to the wire, huh?
Maybe that's compensating for not having anything to report.
Ooh. Ooh.
Show of hands, what do you guys think? Do they have an advantage by having more computers? Because it seems like pure computing power has got to be worth something. But then, of course, there is a Mac on this side, so...
I didn't see any hands, Jacob. I think they're holding back on you. These guys have kind of switched it up now, though. It looks like Toshi is back into manual testing, and oh no, they're both doing manual testing stuff.
Toshi still has his 128 point font too. How about the audience? Anybody find any bugs yet?
Do I hear two?
Nobody?
2 bugs. Yes to 2 bugs. 10 bugs. No takers on 10 yet. Okay.
We'll take well presented but unverified.
Hey, if we run out of time here, I understand they're going to turn the lights off on us at the end of the show. But people who did find their own bugs, please do come up here because we want to make sure we give away a seat with the real food tonight at Bouchon. Hey, why are my slides up over there now? That's not very much fun to look at.
How do we do that? Toshi's trying to get out of the hot seat here. Or maybe he's shooting for that suspense just before the presentation. You don't want anyone to know what your dish finally looks like.
How many more minutes?
5 minutes and counting.
Wow, I thought Sean was into the end run, but now he's flip him back on, Jacob.
Get
He's
ready,
gone
Sean.
back into bug hunting. Either that means he's really confident about his results.
Dude, I'm in PowerPoint.
Oh, he's back in PowerPoint. Oh, look at that.
He's just
doing
getting
screen
screenshots.
captures.
Now, we had a dry run of this a week ago in our office. Different code base. These guys haven't known a thing about it, I absolutely promise. And we had a little discussion about what the presentations were going to look like at the end. Sean vehemently stated he would not be using PowerPoint. So I'm a little intrigued by his decision. Oh, he says it was disinformation. He was trying to throw us off.
Toshi's got results up on his screen, but he's checking in with Eddie. It looks like they're working on putting together the presentation.
His coverage numbers look pretty good, though.
Where's he at? Oh, it's up there on the screen. Read some of them to us, though, Jacob.
Process attack surface 100%. Missed 100%. Oh, no, I guess his numbers aren't so good. That was that. If you only hit 1%, you might want to keep testing case I was talking about before. Sorry. I read these entirely backwards. His coverage numbers actually don't look that great. He might want to go back to manually testing.
Ooh, with just a couple of minutes less, I guess it'd be kind of a Hail Mary.
Of course, today we're not going for completeness. We're going for shock and awe. 45 minutes, what's the best thing you can find?
Jeff?
Something interesting must be going on over here on the screen you guys can't see. Not for long, though. Well, that looks interesting.
What's he doing, Jacob?
He's tinkering around with his cross-site scripting exploit, but I'm not sure what he's trying to do with it.
Jeff is running down to the wire.
And they're whispering, so I can't tell.
Jeff is going down to the wire. He's still going through results. Jacob, time
Sean's
check.
making a title page.
Dang.
3 minutes to go. Now, the question they've got to be asking themselves at this point, on this side at least, is one really good exploit worth 5 unconfirmed bugs? Which way do you go with the last few minutes? It looks like they're going the exploit route.
I think what's happening on this side is that Jeff has stayed in the IDE and is feeding details over to Sean. No, actually, they've both got the auditing tools up at the same time. So maybe they're still cruising down 2 different bugs.
That's a nasty data flow path Sean had up on the screen. Whew.
Sean had a lot of bugs to pick from, though, in his total list. The total number of findings from the source code analysis tool was, is that 35,000, Sean, or is that 3,500? 3,500 issues that the static analysis tool spit out for him to look at. 128K lines of code.
Sean might have done a little customization before he came in today. He alluded to the fact that he was planning to use some custom rules, too.
So that's actually not a bad technique in a really time-crunched environment. He might have turned on some rules that had a whole lot of noise, but that he could sort through very quickly manually.
JSP Wiki has detected an error. We spent a lot of time on that error page. I hope it's interesting.
Has JSP Wiki joined you as a third member of the team, detecting errors in its own code? We ought to be just about at the end of the time, huh, Jacob?
1 minute.
1 minute before Toshi begins presenting to the judges.
Oh, Eddie got kicked off his own keyboard now. This can't be a good sign. There's some dissent amongst the ranks. "30 seconds. "15. And that's time. All right, no more bug finding. Hands off the keyboards. I don't know if it's just the lights, but they're sweating a little bit, and I expect it's going to get worse when they have to start talking to these guys.
Toshi, are you ready to present your results?
Sure.
Let's get you a microphone.
Wow. Party foul.
Uh-oh.
See, we really have tried to sabotage this presentation. Brian just poured water all over the top of the table.
Toshi's too fast for me. His computer made it out alive. All right. Well,
Have we got a mic?
Can we get you a microphone?
Sure.
Maybe you can pick that off of there? Or, well, I guess I've already disturbed all the things that are disturbed, huh?
All right. So basically, what we've done is we've been fuzzing the application wiki, and seems like we've gotten about 17 or so results. Going into details, we can actually see that these URLs with these parameters seem to have cross-site scripting problems. I've got an internal browser in here, and over here, all the alert box pops up, so I can actually verify that these are indeed real vulnerabilities. Same with the other URLs as well. All these seem to be real cross-site scripting problems. And I can go through all of them.
Are those screenshots popping up, or are those the real thing, Toshi?
These are not exactly screenshots, but these are rendered versions of the response. So over here, you can actually see parts of the HTML being rendered over here.
So how many cross-site scripting vulnerabilities again?
13.
13.
Now, in addition to cross-site scripting problems, we found 2 other categories of vulnerabilities. One is directory listing problem, and you can actually see that these are directory listing problems over here. And I can go into my running application, And then, let's see, what was the URL? Templates. And I can actually see that these directories actually do exist, and I can verify these.
Is that a bug with the application or the way the server is configured?
This is the problem lies in how the web server is configured.
Okay.
All right, and there is one more category of vulnerabilities that we found, and I'm going to let Eddie talk through those.
Sure. So when we discovered the cross-site scripting, actually, I noticed that most of them were due to an error page. So even though a lot of these cross-site scriptings were reported at separate URLs, they manifest themselves because of an error page, which I'm sure you guys saw earlier. All right, let's skip that. I'll just show you the code. Here we see error.jsp. Basically, there's information leakage here, and it prints out the actual class name and line number in the code where this exception is thrown. So we're able to determine what kind of structure they're using in their code, and a lot of the cross-site scripting is actually reflected here too.
All right. Thank you. Let's hear from our judges on what they think about that first Toshi's presentation.
Mr. Viega.
So take points off for having 3 machines up there. There are 2 of you. Don't you guys use VMware or something like that? You never heard of virtualization or anything? I mean, come on.
It's faster.
Yeah, all right. Well, touche, sir. Touche. So let's see. How many false positives did you identify when looking through your results?
So far, we don't think we found any false positives. So in all of the cross-site scripting problems, we were able to actually pop up a dialog box. And then the directory listing, we verified those. On the other hand, there might have been false negatives that we've missed.
So what do you think the most obnoxious thing a bad guy could do here would be?
Defacement.
Defacement. All right. Well, anybody can deface a wiki, so I think that.